All right, so in tonight's notes, we're going to be working a lot with the unit circle, and we're going to be generalizing triangles inside of the unit circle to determine the signs of each of these functions in each quadrant. So in order to show you what I mean, A says that we need to draw a triangle, a right triangle in quadrant 1, and it's just going to be a generic right triangle. It's not necessarily a 30-60-90 or a 45-45-90. We're just going to draw a right triangle in here, and we do not know the lengths of the sides. All we know is that it's got a right angle here. So what it says to do is evaluate the three major trig functions for unknown values of theta. So like I said, we don't know what theta is. We don't know the measure of that angle there. So we're going to have to figure out what sine, cosine, and tangent are. So before we do that, I want to determine what this point is right here. In order to know that point, we would have to have some x value and some y value, right? So we're trying to figure out what is the x value of this coordinate. How far over is it? Well, we don't have a number for that, but we do know that however far over it is will be this x value, right? It's just going to be some generic x, because the length of the bottom of this triangle is whatever this length is. It's just some horizontal length x. And the y value of this coordinate is just going to be some vertical value y. It's whatever the height is, right? Because the height of this triangle is wherever that point is. One thing we do know, though, is we know that the hypotenuse is 1 because we've set it inside the unit circle, so we know that that length is definitely 1. So when it says to find the values for sine, so we're going to find sine of theta, we're going to find cosine of theta, we're going to find tangent of theta. We're going to use these lengths. We're going to use x, we're going to use y, we're going to use 1 for the hypotenuse. So sine of theta, well, sine is opposite over hypotenuse. And if we're at theta, that means that the opposite side is y, and the hypotenuse is 1. So that means that sine is going to be whatever your y coordinate is over 1, or just y. So sine is whatever y is in quadrant 1. Cosine is going to be the adjacent side over the hypotenuse. And in this case, that's going to be whatever the x coordinate is over 1, or x. And tangent is just a little different. That's opposite over adjacent. So that's going to be whatever your y coordinate is over whatever your x coordinate is. So that's y over x. And that's all this is. This is just very generic. What is the value of tangent of theta if we don't know the side lengths? And eventually we are going to know the side lengths, but we're going to generalize it first. So that makes sense if we're in quadrant 1. But then it says, what would be the sign of each trigonometric function in B if it were located in each quadrant? So what I'm going to do here is I'm just going to draw 3 more triangles. I'm going to draw one here, I'm going to draw one here, and I'm going to draw one here. Okay, so we already had a triangle in quadrant 1. I've placed one in quadrant 2, I've placed one in quadrant 3, and I've placed one in quadrant 4. So what we're going to see is, does this change if we're in different quadrants? Because that's going to start to determine the value of these trig functions if we get angles that are bigger than 90 degrees. So in quadrant 2, if I have sine, that means that I have opposite over hypotenuse. And in this case, sine would still be y, whatever your height y is, and the hypotenuse would still be 1. So sine would still be y. It's a little different for cosine, though, because if we go this direction, our x value isn't going to be x anymore. It's going to be negative x. So cosine, since it's adjacent over hypotenuse, is going to be negative x over 1, or negative x. So cosine is actually negative if we're in the second quadrant. Tangent in this quadrant is going to be opposite over adjacent. So let me just remind us here that these are our angles. That's theta. That's going to be your opposite side, which in this case is y, over your adjacent side length, which here is negative x, which means that tangent is also negative in quadrant 2. So it's important to note that in quadrant 2, sine is the only trig function that stays positive. the other two would both be negative. In quadrant 3, let's see if anything changes. Well, our x value here is still going to be negative x, but notice now that we're in quadrant 3, our y value is also going to be negative. So since sine is opposite over hypotenuse, and hypotenuse is still 1, that means that it's going to be negative y. Cosine is going to be negative x over 1, and tangent now is going to be negative y over negative x, which actually is going to become a positive y over x. So in quadrant 3, tangent is the only function that's actually positive. In quadrant 4, we have sine, which is your opposite side. Our opposite side length here is also negative because it's beneath the x-axis, so our y values are negative. So we have negative y over 1. Cosine is positive again, because notice our adjacent side length is a positive x. So that's going to be x over 1. And tangent is going to be negative y over x, which is again negative. So cosine is the only positive one in quadrant 1. Notice they're all positive in quadrant 1. In quadrant 2, it's just sine. In quadrant 3, it's just tangent. And in quadrant 4, it's just cosine. So there's this acronym that we use if we have a coordinate plane to help us remember. We say add sugar to coffee. It's just a phrase that helps us remember that in quadrant 1, it's all of our functions that are positive. In quadrant 2, it's just sine. In quadrant 3, it's tangent. And in quadrant 4, it's just cosine. So now we're going to use this information to help us calculate the value of a trig function that's not in quadrant 1. It says to calculate cosine of 120 degrees. So what we'll always do is we'll draw a little coordinate plane here that will serve us just for this problem. 120 degrees is going to be somewhere around here. So what I'm going to do is I'm just going to draw a right triangle where this is 120 degrees. It is right. And we're going to put it in the unit circle, meaning that has a side length of 1. So the question is, what type of triangle is this? Well, if this is 120 degrees, all we have to know is the reference angle to know what kind of triangle this is. So we'll just figure out what that reference angle is there. That's going to be 180 minus 120. So now we know we're working with a 30, 60, 90 triangle. Okay. So what we're going to do now is we're going to actually transition. Instead of using 120, we're now just going to find cosine of 60. And in the end, the way that we're going to make it work, so we remember that we're using 120, is we're going to change the sign if we need to, depending on what quadrant we're in. So as long as we use the reference angle, that's okay if we change the sign at the end, or adjust it to whatever the sign needs to be. So cosine of 60 is all we got to figure out now. Well, in a normal 30, 60, 90 triangle, we have side lengths of 1, radical 3, and 2. But the hypotenuse just became a 1. So that must mean that we divided each side by 2. So our side lengths now are 1/2, radical 3 over 2, and 1. So let me just label those. And now we can finally figure this out. Cosine of 60 is going to be our adjacent side over our hypotenuse side, which in this case is going to be 1/2 over 1. And that's why it's nice to use the unit circle, because we're just going to be dividing by 1. So cosine of 60 is 1/2, but remember, we're trying to find cosine of 120. So in order to find cosine of 120, what we have to do is we just have to check, should this 1/2 be positive or should it be negative? If we go up here to what we just did, it looks like in quadrant 2, which is where our triangle is, cosine is negative. And we remember that too from our acronym, add sugar to coffee. Sine is the only function that's positive in quadrant 2. So, because sine would be the only positive function in that quadrant, this must be negative. So sine of 120 is negative 1/2. And we're going to be practicing a lot of examples like this in class tomorrow. I know that it's really intense and there's a lot to this. So I would encourage you to watch the video again. If there was any part of it that confused you, rewatch it. Take more notes over here in the margin, things that confused you. things that you need to remember, connections you made. These are your notes, so take your time with these. I'll see you guys tomorrow.